Okay, so what's now happening, it's recording what's on the screen there and then audio from the room, right? So if you ask a question, it may or may not pick it up depending on the sensitivity of the microphone. But, all right, so we're going to start off by factoring. We have two worksheets to do, which is the Are You Ready for Calculus and the piecewise functions. We'll get as far as we can get today in this, right? So we've got whatever amount of time, and then tomorrow we'll finish this off and do piecewise functions. And then you've got the weekend to kind of look through that stuff if you want. And then on Monday, we start in with the real stuff, which is limits. Okay? So, what do we do first? Factoring. What's the first, always the first step in factoring is to common factor. So is there a number which is, line's too thick. Is there a number which is common to negative 2, 20, and, that's the way it is. And 48. 2. Want to take out 2 or negative 2? Let's take out a negative 2, giving us a nice positive experience with the rest of it. Negative 2 what? What else is common? X squared. So negative 2x squared is our common factor. Now put down brackets, and what do we need? So how do I make a negative 2x to the 4th? We need an x squared, right? Okay, plus or minus? Minus, because we took a negative out. Okay, minus, how do you get 20 if you got a 2 there? So 10x plus or minus? Plus what? 24. 24 what?
Bracket.
Just 24. Yeah, close parenthesis, right? Does this factor? And by this I mean this, because when I say this on the video, it's does this? What the hell are you talking about? So does x squared minus 10x plus 24 factor? Yes. Okay, so factor. You should all be able to factor trinomials by now, right? What two numbers? Multiply to 24 and add up to 10.
Will it record what we're saying like back here?
If you saw the little green thing move, yes it will. Likely. Okay, so there's your, yeah, yes, no? Yeah, good, done, correct. Oh, by the way, you got to fix all my mistakes, so. Oh, yeah. Okay, 6x cubed plus 14x squared minus 40x, same deal, right, basically. What's the greatest common factor? Number that goes into 6, 14, and 40 is? 2. They all have at least one x. So what power of x?
X.
Just x. Leaving me with? X, throw it out. What is it? Plus 7x. And?
1.
Does that factor? Probably. So if it does, we're going to have a 3x and an x, right? So we get 3x squared. Need two numbers to multiply to negative 20. Probably 4 and 5, so let's see. If I stick a 5 here, that'll give me a 15. And a 4, that won't give me a 7, so that's no good. So what if we put a 4 here? That'll give me a 12, and a 5 here, and then that should be positive and negative. So 3x squared plus 12x minus 5x is plus 7x. Let's wait that up. Minus 20, which does work. Okay. (256) a to the 4th minus 81. What's this called? Difference of squares, right? So they both have square roots. What's the square root of 256 a to the 4th? 16a squared. What's the square root of 81? 9. Okay, so we know it's a plus b, a minus b, right? That it's of that form. coming back to you? Wow. It hasn't been that, well, for some of you it's been a while since you did 30-1. Anything else I could do with this? There's another difference of squares, right? So you should always be suspicious, especially when you see a fourth power, say, there could be another difference of squares. That's the reason why I write the positive one first, right? Because this is the one that I'm then going, this can't factor again, right? Can't do anything with the sum of squares, but this can. So I always do my plus, then my minus. Okay, so 16a squared plus 9, and then, what is it? Be afraid.
4.
Okay, so again, it's the square root of the first term plus the square root of the second term, square root of the first term minus the square root of the second term, right? That's how we factor difference of squares. Yeah, so anytime you see something up here that you have a question about, please ask. Okay, let's slide this back over. Let's make this big. What do we do here?
Is that like all you have to do if you're going to do that 16a squared
Plus 9. Yeah,
times that? You don't have to factor over that again?
you can't. A sum of squares can't factor. A sum of cubes, on the other hand, we'll see here, that can factor. Okay, what do we do? What's our first step here?
Common factor.
Common factor. Okay, what's a common factor?
X minus 3.
Well, yeah, and what else? So we got 136. What's the biggest number goes into 100 and also goes into 36?
4.
4. So 4 and what? So we got a 4x and an x minus 3, right? That's our common factor. Okay, and we put another set of brackets down. So 4x times what would give me 100x cubed?
20x.
Let's go with 25.
25.
25x squared, right? So if you multiply this times this, we just got this first term, right? So then we got to put down a minus sign. So 4x times what gives me 36x? 9. And you already got the x minus 3, right? Got to go. Anything else we can do with this? Okay, so do it. You do that, I'll do this. Oh, don't forget an equal sign. And what goes in here?
X plus 5x.
5x plus 3, 5x. So again, it's a difference of squares, right? Okay, question. I'll leave that for a second. And I'll still bump it, but I'll say
Yeah.
gauge. Okay, ready? This, what would we call E? A sum of cubes. Can we factor a sum of cubes? Yeah, otherwise we wouldn't ask you to, right? I say factor if it doesn't factor. So how do you factor a sum of cubes? So, oh, now I get the thin line. Oh, wait, because it's normal size. Okay, so let's say we have something of this form, a cubed plus b cubed. So I've memorized this much of a sum of cubes. I know that if it's a sum, then it starts off as a plus b. Okay, so that's one of the factors. So what are you going to put here so you get a cubed? So this times a squared. What are you going to put here so you get plus b cubed? And what about it? Is it plus b squared or minus b squared? It's got to be plus b squared. And what are you going to put here so that all those other things are going to cancel out? We're going to put this, minus ab. So now if you multiply this out, right, how many products will we get if we multiply? 2 times 3. 6, right? 6 products. So we're going to get a cubed minus a squared b plus ab squared plus a squared b minus ab squared plus b cubed, right? So minus a squared b, and we're just left with a cubed plus b cubed. Similarly, So when you want to factor a difference of cubes, you start off with a minus b, right? You take the cube root of the numbers. And then you need an a squared, right? That's the only way you're going to get a cubed. If I want to get a minus b cubed, then I better put a plus b squared. So what's going to go here? Well, it's either minus ab or plus ab. Well, we already used minus ab. Let's try plus ab. Okay, so a cubed plus a squared b minus a squared b, right? Plus ab squared minus ab squared minus b cubed, right? So similar deal, right? It's just that, look, I'm going to cancel them, one right after the other. So that's sum and difference of cubes, okay? I wouldn't, the only thing I'd memorize is that if it's a sum of cubes, it starts with this, because that's pretty easy to find, right? Like, take your moment, but if you want to memorize it, there's this acronym which was like SOAP. Well, it wasn't like SOAP, it was SOAP. Which says same sign, and then opposite sign, and then always positive. Right? I wouldn't memorize that because, it's not like you're gonna, if we were doing a lot of these, I would memorize that. But you're not, you're gonna be called upon maybe to do a sum or difference of cubes. Just remember that one of the factors is the cube root plus the cube root for plus, the cube root minus. You'll figure this out pretty quick, right? I mean, all you really need to do is something like, well, just do this, a cubed minus b cubed, and write it out and play with the signs and figure it out. Okay, so what's the cube root of this? 5m plus 2. The thing about the afternoon is the questions are going to be often rhetorical. What's the cube root? We don't know. It's the afternoon. Especially, how many of you wrote chemistry yesterday? See, this is unconscionable. Ooh. Okay, so then it's a again, right? It's a squared. So now we got to go 25m squared plus ab, right? Or sorry, minus ab, right?
Could you put 5m in brackets and then square?
Yeah, but I wouldn't. You can if you like, but don't. Okay. Well, here's one thing about factoring. What's one thing? What should you always do after you have factored something? You should always check it. Okay. And especially, in calculus where it matters, because it's not like math 10C. You factor something, it's like you get a mark or you don't get a mark. In calculus, you factor wrong, it's like, and now you go on for 3 more pages, and then you come to realize at the end that, I made a mistake back here, and now might as well just get new pieces of paper out, right? Because there's no point erasing that much. Well, you need a really good eraser, okay? Trust me, really good eraser. So check it, right? So go, and I would check this. So 125m cubed minus 50m squared plus 50. So I would do like one of these and one of these because they'll be canceled, right? So minus 50m squared plus 50m squared plus 20m minus 20m plus 8, right? Easy way, but I would kind of alternate these guys so that you're doing the plus one, the minus one, and you just sort of say, yeah, those are going to go away. Okay, questions? Comments? Concerns? What's this? Does this have a cube root? And what is it? 3x squared. Okay, and then just having done it, we know that it's the, whatever, it's the square of this, so that'll be 9x to the 4th. And this has the opposite sign, so it's plus this times this, which is 3x squared, and then it's plus 1. Okay, and then we're going to check that. Right? So we have 27x to the 6th plus 9x to the 4th minus 9x to the 4th plus 3x squared minus 3x squared minus 1. Right? 2 thumbs, you can't see this. Well, you can see this, but they can't. 2 thumbs up. Wait. Okay, have you all had your moment? I'll get a drink. Try not once I spilled on the computer, it wasn't a good idea. But that was the old ones, these are new.
This little clicker wants to flip around.
G. Now we're
There's
gonna
two
do
Gs.
a bunch of these. The two G's.
Two Gs.
Okay, so this is the first G.
That's GG.
Okay, so we will determine this one to be G1. So we'll put a little G sub 1. G sub 1. What is the, so let's start with 6x and 10x squared. What's the biggest number that goes into 6 and 10?
2.
2. What's the largest power common to x and x squared? Okay, so we got 2x. Now, so we always go with the smaller power, right? So when we look at these guys, we say you got an x and an x squared. The smaller power is the common one, right? One I could take out. So we've got a 3/2 and a 1/2. Which one's smaller, 3/2 or 1/2? 1/2, right? So that's going to be common, right? So x plus 2 to the 1/2. So that's our common factor, right? I hope this makes sense to you because you're going to be doing a lot of it, right? So just, okay, let me put down a bracket. So if I want to get a 6, then 6x, I've got 2x, then I need to put down a 3, right? Okay, so 3. What do I need to put to get x plus 2? So if I'm multiplying something by x plus, well, it's going to be an x plus 2. So how do I get an x plus 2 to the 3/2? I've got a 1/2 multiplied by a whole, right, which is 1, which is 2/2. So we multiply these two guys together, like base, right, multiplying powers with the same base, right? Then you add the exponents, so we've got a 1/2 plus 1. That's going to give us 3/2. Okay. Then we go here and we say plus, well, 5x, right? 5 to get to 10 and then x. We've already got the x plus 2 to the 1/2. Okay, so we're done. Are we done?
Yeah.
No.
No.
Because what can you do with this?
Expand.
You expand it and collect it, right? Okay, throw an equal sign down there. So it's going to be equals 2x, x plus 2 to the power of a 1/2, 3x plus 6 plus 5x.
Sweet.
Okay, so we're just expanding this, right? 3x plus 6, then plus 5x, right? So common factor stays the same. There's nothing that's changed out here. It's x plus 2 to the 1/2. And then in here we've got what? 8x plus 6. Are we done? Not yet. Because there's a common factor inside that last bracket, right? Because there's a number that goes into both 8 and 6, which is 2. So we're going to pull a 2 out of here. Now when we pull the 2 out of here, it goes up here, and then we're going to write what number?
A 4.
We're going to write a 4, right? So we're taking 2 out of here, pull it out, stick it in front, just say, well, okay, we got 2 times 2, so that's 4. Then the x plus 2 to the 1/2. And then what we're left with after we pull the 2, which is 4x plus 3. Are we done? Yes, finally. Welcome to calculus, because that's what it looks like, right? Well, it's not really, but that's kind of idea is that there's a lot to go through, right? There's a lot of steps, right? It's just all algebraic manipulation. I think I mentioned something about algebra might be important. So there you go. And one of the big concepts is factoring out rational powers, right? So the idea of factoring out, but you know, it's easy, right? All you just say, which one's smaller? They're both x plus 2's. The common factor has to be the smaller one, okay, which is the 1/2, and then I'm left with this. Now usually they're very nice, right? In that when you factor one out, you usually just end up with this to the power of 1. You don't always end up with this to the power. Oh, I factor out a -5/3, and then I end up with a 17/3 or something. Okay, so they're generally pretty nice. Questions, comments? Okay, so G2. Whoops. It's over just a bit. Let's call this G sub 2. Okay, so again, we want to look for a common factor. So let's start with numbers. Between 5 and 10, is there a common factor? 5. Okay. So look, nothing we're doing is hard, right? It's just take it a step at a time, right? I look at the numbers, okay, there's a 5. I see both of them have an x minus 4. Which one is the lower number? -2, right? Okay. So we look at the numbers, 5 and 10x, we say 5 is common. I say, hey, they both have an x minus 4. I'm taking the lower power, which is -2. They both have a 3x minus 7. Which one's the lower power? So what do I write up here? 4. That's your common factor, right? And we put down a bracket. How many terms are going to be inside the bracket?
2.
2, right? Because there's only 2 terms there. Remember, terms are things that are separated by plus or minus. We got 2 terms. Okay, well, this has a 5, so this is the same as this. This is the same as this. This is what? So if I want to get this to the power of 5, and I've already got it to a 4, then I need to write it to a 1, right? Because this times this. So when you take this times this, you get this. Which if you're watching the video is going to, what the heck? Actually, I think you see, it does like little hovery blue things or something when I move close to the board, or maybe not. Okay, then we put down a plus, right? Because now we're doing the second term. So plus, okay, now in order to get a 10x, what do I need? 2x. Now the 3x minus 7 to the 4th we already got, right? So we got to worry about this. So this times what will give me this? So I got -2. So let's write it down, right? We know we need an x minus 4. We just got to figure out what power of x minus 4 do I take -2 times this to what power will give me a -1? Power of 1. Okay. So we just leave it like that. Right? Make sense?
Why not?
Okay. So when you're doing these, right, in your factory, just remember, I always work with the lowest power. That's my common factor. And then I say, well, what do I need to get the power that I have? Well, I need a 5, I've got a 4. Well, you got to add a 1, right? So remember, we're adding, because multiplying powers at the same base, you're adding exponents. And this one, oh, it's a -2. -2 plus 1 gives me -1, so that's why there's a 1 on there. All right, now we collect this, right? So let's throw an equal sign down here. So our common factor stays the same, right? Nothing. Okay, and now we're just going to go through, remove brackets. So removing the first set of brackets didn't do anything too exciting, right? I mean, 3x minus 7 stays 3x minus 7. Then we have 2x times x minus 4, which is plus 2x squared minus 8x. So now we should do what? Collect the terms in the brackets, right? So let's just do that separately. You also need a lot of pencil lead. Okay, so here, you need 2 tools to do calculus. You need a mechanical pencil, right? Because you don't always want to be going up and sharpening your pencil. So you need a mechanical pencil. I use 0.7 because I push way too hard for a 0.5. They just break all over the place. If you really push hard, get a 0.9. You also need a really good eraser. I suggest these. This is a nice little Stettler. It just comes out like that. It's nice, it's handy, it's easy to use. And you'll be using this so much. Trust me. You're using it a lot, so get yourself a good eraser. Okay. So,
Average.
2 things. Oh, one other thing I like, you don't necessarily need, but I love these quad-ruled notebooks. Right, 200 pages. It comes with quad-ruled. I was messing with calculus over the summer, so this thing is. So it comes with quad-ruled paper. It's nice if you have to sketch a graph or something. Then you've got a nice set of grid lines, right? You want to draw a right-angle triangle. I don't know. You've got lines to follow. Okay, so you don't need one of these. You can use a binder, but it's nice to keep things organized. Okay, but quad-ruled notebook, great thing to use. Okay, and they're not that expensive. You can run for a few bucks. Okay, what do we got here? So 2x squared. Okay, so What else? Well, maybe this factors, right? Does it? 2x and x, and then a 7 and a 1. Yeah, I think we can do it, because you throw a 7 with the 1 and a 1 with the 2, then you'll get a 5. Whoa. Okay, so equals. So I need the 7 here and a 1 here, and it's got to be a minus 7. So 2x squared plus 2x minus 7x is minus 5x minus 7. Ow. Okay, questions, comments, other than holy. It's not as bad as it looks. It just looks bad now, trust me. You're just going to have to practice a little lot. Okay. So that's why we've got that sheet for you, right? To practice, and then if there's a lot of factoring in there, and just sit down and pound through it. The answers are all there. Phone a friend. You got the weekend to do it, so you can have a little let's do some calculus or pre-calculus party. Was that it for that page? Then there must be more. Okay, so another part of this is, of course, simplifying rational expressions. Also stating the NPVs, or non-permissible values. If you like, you could state restrictions. Either one, doesn't matter. One is equals, one is not equals. Right? Doesn't. The idea is just to remember that, hey, at some point this thing's not defined because this can't be 0. Right? So, first step. What's first step? Thinking back to 20-1. Factor it, right? Yeah. Woohoo. Here's in math, if in doubt, try and factor everything. Right? You can't go wrong by factoring. Well, you can, but you're not likely to. All right, so what do we got? 5. Okay, so the top is pretty simple, common factor, right? Agree? Is that right? I think it is. I'm not trying to make mistakes now, okay? So occasionally I might, on purpose, make an error. I will make many errors. Most of them will not be on purpose. Your job is to catch them. That's, you got to, the stay engaged part. So you got to say, hey, wait a sec, shouldn't that be a plus or whatever? And if you're wrong, that's fine, because I'll be wrong more than you are, at least up here. So now, guess what? If it's a rational expression, then that has to be one of the factors, because otherwise, why do this, right? I mean, they got to cancel. So I'm not actually going to factor. I'm just going to say, well, then I need an x there and to get a minus 15. So I didn't factor it, but I'll bet that's the factorization of it. Right? So that's what you do in rationals. You probably picked that up in 20-1, right? Because well, I know things are going to cancel, and the only thing that I can use, I can't do so 2x minus 3 has to be the thing that cancels, but I should check, because what's the second step in factoring? Well, it's guess and check, right? So 2x squared plus 10 minus 3 is plus 7 minus 15. Huzzah. Now what do? What's the next thing you do? NPVs, right? So are NPVs the ones where we say equals or not equals? If it's not permissible, then it must be equal to, right? Because it can't be equal to this. Restrictions are not equal to. Okay, so x equals what? Well, let's go negative first. Negative 5 and 3 over 2, right? Okay, so first step is to factor. Second step is to state non-permissible values from the factored form. And then we simplify. Okay, now, can we get rid of anything else, right? I mean, we might as well. We got x's on the top and the bottom and 5s. Surely something. Can you cancel anything? No. Good.
Why is it x can't equal if it's a non-permissible?
Non-permissible values are what it can't be. Restrictions say x is not equal to. That's restriction. X cannot be equal to. A non-permissible value says if you use this value. You know what? I've just soon state it as a restriction. Just say x cannot be equal to. I mean, I think it's nicer that way, right? You're saying this is what it can't be.
That's how hard it can be.
Okay. Next. Oh, now we get into the fun stuff. Okay, so do this one on your own. No. So this is a complex fraction, right? So we call it complex fraction. Well, it's not really complex in the sense of, square root of -1 complex. So here's what we do. I'm actually going to start here because we might need some room. So the first thing we do is we're going to add or subtract the top. In order to add, so forget the h on the bottom, right? Forget this. In order to add or subtract fractions, we need a common denominator. Okay? So what is the common denominator for that? Actually, I can that. What's the common denominator for x plus h minus 1 and x minus 1? X plus h minus 1 and x minus 1. Right? So there's the common denominator, right? So we take this first 3 sitting here and we say, okay, so that 3 is this 3 and it's already over this. So what does it need? So in order for this expression here to equal this, it needs an x minus 1 up here, right? So what we now have is the left expression written with the common denominator. And now we go minus 3. And what does this expression need? So forget this, just say I'm trying to get the second expression. So it needs an x plus h minus 1, right? Now I'm not going to throw that whole thing over h, right? So this whole expression is divided by h, but the easy way to do that is just to multiply by 1 over h. Right? This way I now just have a single numerator and a single denominator, right, instead of multiple denominators, which is confusing. Okay? So we just say, well, the whole thing's divided by h, just multiplied by 1 over h. A sort of shortcut over the years I've figured out is, that h there, it just ends up in the bottom anyway. But that's why, because you're just multiplying by 1 over h. Okay, so now we expand, simplify, blah, 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 right? So we get 3x minus 1 minus 3x minus 3h plus 3. What did I mess up? Ah, good. Not even on purpose, but that's good. It's good. You guys are good. We will save. You'll be amazed how much time we will save if you catch this stuff as it happens. Because some of this stuff goes on for like 4 boards, right? And if you wait till the end, you get to the end and you say, back there, isn't 2 plus 2 really 4? And you, I think it might be, and we'll continue this tomorrow, right? Or I will post a video tonight of the actual, for real answer, and now you have to watch it all over again. Man, I wish I'd done that on purpose. Okay, so 3x minus 3 minus 3x minus 3h plus 3 all over, okay, we got our h, we got our x plus h minus 1, and we got our x minus 1. Okay, so everybody look at that, wrap your head around it, or stuff it inside your head somehow, because you can't really wrap your head around something.
Should we expand the bottom?
Other than a tree or something.
Should we expand the bottom?
Never expand the bottom.
Sounds good.
Yeah, no, with rationals. No, what we should do is say, well, look, what do we have? We got 3x minus 3x. What's that?
0.
0. We got negative 3 plus 3. What's that?
It's 0.
So 0. So we got a negative 3h. Negative 3h. Wait, let's center that a bit better. So we got a negative 3h over h times x plus h minus 1 times x minus 1. Now what do? Cancel the h's. Oh, wait, we're supposed to do non-permissible values, which we should have done way back here. Weren't we? Or were we? No, we weren't. Well, what would they be? Well, you'd say something like, well, h can't be 0, right? Because if h were 0, then x can't be 1, right? Because that's... And then x plus h can't be 1. So I guess that, but it didn't ask for them, so. But you just need to keep in mind h can't be 0, you'd be dividing by 0. X minus 1 can't be 0. And x plus h minus 1 can't be 0. All right, so then the final, why is it doing that? So your final answer is negative 3 over x plus h minus 1, x minus 1. Okay. Questions, comments, concerns? No. You're going to see this a lot, like this type of, what we just did, you're going to see this repeated. So this example didn't come out of nowhere. Is there more on this page, or is that it for the page? No. Where'd it go? Maybe it's on the next page. Is this the next thing, or no?
Yeah.
Yeah? Oh, okay. Pages are different. And I just made this like really, really big so that I could write big. And like 300%. Determine f of 10. What's determine mean? You didn't see it on the diploma. Really?
Yeah.
Show your work. Yeah, show your work. Okay. So what do we do?
Put 10.
Put the 10 in. So we say f of 10 is equal to what?
30.
Well, let's actually show the 10 going in there, right? So 3. So first step is just to say, hey, it's a function notation, and I'm doing f of 10. So everywhere I see an x in the function definition, which is f of x equals 3x over x minus, I'm going to write a 10. Okay, done. Now, what's that equal to? 30 over root 8, right? 10 minus 2 is 8. Are we done? No, because root 8 is 2 root 2, right? Which makes this 15 over root 2. Are we done? No, because you can't leave a radical in the denominator. So if I wrote 15 root 2 over 2, would anybody get too excited and say, where did that come from? Okay. Here's what it came from. I'll do this in red. Or not. Go back. So what do? You're going to multiply by root 2 over root 2, right? That's rationalizing the denominator. You multiply by the same radical. Okay, so we get 15 root 2 over 2. Nothing simplifies. Now we're done. Give me a moment, wrap your heads around that. Remember, you can watch this over and over again if you want. I think it's still recording. Oh yeah, I see the numbers are counting there. And remember, if you just want to watch part of this, the nice thing about YouTube is you get all little thumbnails at the bottom. You can just skim through until you recognize the part of the worksheet where you're going, what the heck happened here? And then just watch that, right? So it's not like, I mean, if you miss the entire class, yeah, you want to sit and watch the whole thing. But if you just, tonight you're looking at that and going, what the heck happened in that one example? Drag your way through and just watch that one example. Okay, determine f of x plus h. You're going to see this again, this foreshadowing if ever there was. F of x plus h minus f of x over h.
What's up the next question?
Yeah, no, it's if f of x is equal to 2x squared plus 3x plus 8. All right, so what do? Well, we start off by saying, okay, I'm going to do this, f of x plus h. So that's 2, and I'm going to replace the x with an x plus h, right? And then that's squared. Plus 3, and I'm going to replace the x with an x plus h. Plus 8, so this is this, right? So just take a moment, that's all we've done so far. We've just done f of x plus h. We substitute x plus h in for x, we've written it. So minus f of x, which is just this, right? So 2x squared plus 3x plus 8. Now if you want to do that, this better be in brackets, right? Because we're subtracting that whole thing. Okay? I don't need brackets there, but I like putting them in because it just lets me know that, this is, I'm going to work this out, then at some point I'll remove the brackets, which will do nothing to this. It'll be exactly the same. All over h. Now what? Well, now we square that and we expand that and we collect that. Right? So now we just do some algebra. Equals 2x squared plus 2, oh, let's go alphabetical order, plus 2hx plus h squared, whoops, don't do that. Oh, no, do that. Plus 3x, oh, don't write this big, plus 3h plus 8 minus 2x squared plus 3x plus 8. All over. And don't forget this, right? And you see this in 20 a lot. It's like, oh, I got tired and I couldn't write the denominator in. But I'll bring it back in 3 lines, don't worry. Right? You can't do that. You got to write the denominator, right? Otherwise. You can't do that! Right? Can't do that. One more time. You can't do that! I've been saving that up for this. I'm just leaving that. You guys are going to say something, I'm just going to go. Equals. Okay, so now we go through, we expand further this set of brackets, right? 2x squared plus 4hx plus 2h squared plus 3x plus 3h plus 8 bracket minus bracket 2x squared plus 3x plus 8 close bracket. Draw a line, put down the h. Okay? Just algebra, right? And it's actually, it's relatively simple, right? We're just multiplying stuff out and collecting it. Okay, equals. Now we'll do two things. So we'll collect these terms and remove the brackets at the same time, right? So I'm now going to write this out, removing the brackets. It'll be 2x squared plus 4hx. Well, actually, there's really nothing to collect there. Plus 3x plus 3h plus 8 minus 2x squared minus 3x minus 8 all over h. Okay, so now we just removed the brackets, right? And when we did that, we changed the sign of everything in the second set of brackets because there's a negative in front.
Where did you 2h squared go?
Yeah, 2h squared.
That's a good question. Good thing you guys are paying. Plus 4. I wish I could say I'd done any of this on purpose. That's good. I'm training you. Okay, so what do we got? 2x squared and minus 2x squared. 3x and minus 3x, plus 8 and minus 8. So, okay, what's left? We got 4hx plus 2h squared plus 3h all over h. And what's the last step? Divide out the h, right? So all of the terms up top have at least one h. So you can divide h into all of them. You get 4x plus 2h plus 3. Is that right? I can check my answer sheet to make sure. Should be good, right? You've been checking me as we go along. So yeah, 4x plus 2h plus 3. It's all good. Next. Rationalize the numerator. I know, right? Rationalize the numerator. So why would you want to rationalize the numerator? Well, you'll find out in a few days, or a week, or I don't know. Soon you will understand. Okay, if I want to rationalize the numerator, what do I multiply by?
Square root of x.
The square root of x plus 4. And then plus 2. Right? So basically these same two terms, but with opposite signs. Right? So that we end up with this plus 2 times this minus 2 times this, right? They go away. So the radicals go away, right? That's the whole idea between, again, rationalizing. But you can't just multiply by it, so what goes on the bottom? Same thing, right? So we're going to end up with a rationalized numerator and an irrational denominator, right?
Wouldn't it be that?
Okay, so we get root x plus 4 times root x plus 4, which is just x plus 4, right? So when you square something, you just remove the radical sign, right? Just x plus 4. So don't try and say, oh, it's x squared plus 8x plus 16. It's not, right? It's just root x plus 4 times root x plus 4 is x plus 4. Just like root 9 times root 9, it's not root 81. Well, it is, but you don't think of it. Just root 9 times root 9 is 9. Okay, so x plus 4. Okay, then we get plus 2 times root x plus 4 minus 2 times root x plus 4. So they're gone. Right, I'm not going to write them out. And then you get minus 4, negative 2 times 2, right? Over which is equal to because plus 4 minus, which is equal to
Plus 2 on the bottom, isn't it?
yeah, it is, isn't it? I should be doing these on purpose. Maybe I am. I'm just trying to make you feel good. Now you're getting worried. Well, he doesn't even know how to do it. Okay, so you end up with 1 over the root of x plus 4 plus 2, right? But we have a rational numerator now, right? And there are reasons we do this. You will see. You will soon see.
So that's complete.
Yeah, that's done. Okay, because what we've done is the instructions were rationalize the numerator and denominator, and we've rationalized the numerator, right? Because the numerator had a radical in it. So now we want to rationalize the denominator. So what are we going to multiply by? Okay, well, it's going to be this minus this, right? So same two terms, and we're going to have to do that on top. And we're going to have to do that on the bottom. What's this equal to? 1, right? So we're not actually changing its value, right? We're just changing its form, but not its value. Keeping in mind, you know, there are non-permissible values. We can't end up with a 0 on the bottom. So. Okay, equals. All right, so. Okay, so it's just x plus 1 times that expression. Over and we're going to multiply these guys out, right? So what's this times this? Root x squared minus 4 times root x squared minus 4 is x squared minus 4. Minus one of these and plus the same one, right? That's the idea in rationalizing is they're going to cancel, right? And then we get minus, so we better throw bracket there, minus what? And you know what? Let's throw brackets around this too. Minus, so what's root 4x plus 1 times root 4x plus 1? 4x plus 1. So I'm going to bracket this and bracket this, then we'll pull the brackets off and then we'll collect the terms and we'll see where we're at. So equals x plus 1 root x squared minus 4 minus root 4x plus 1 over x squared. All right, yeah, I'm gonna do this in one thing. So I'm gonna go x squared. It's gonna be minus 4x. And it's going to be -4 minus 1, so that'll be -5. Okay, and I've kind of done two things at once. I didn't remove the brackets and then collect, I did them both together. But and I bet you we can factor that and get one of these factors to be x plus 1. So they'll cancel. So we got x squared minus 5 plus 1 is minus 4x minus 5. Cross those off. And now we can write our final answer. Okay, which is the root of x squared minus 4 minus the root of 4x plus 1 over x minus 5. Keeping in mind all the associated non-permissible values, things, numerator, denominator can't be 0.
It was like all this stuff questions. Like easier with.
Shall we stop there? Because we're almost out of time anyways, right? So.
And base scores.
Let's see, what's left?
I got 42 out of 9.
Yeah, so we got a bit more to do.